What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram. Drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best.
Alright, 060612 May-June 2021 paper. Okay, so this is the paper 1 paper and we'll go through the entire thing. Alright, first question. Write bracket PQR bracket to the power of -2 R to the power of 1 over 3 divided by bracket P square R bracket to the power of -1 Q cubed in the form PA, QB, RC. So this is an indices kind of question. All we need to do is apply the law of indices. Okay, so the first one, if there's a bracket, we multiply, multiply, multiply. So what would you get up here? P -2, Q -2, R -2. Then over here, we've got our R 1 over 3. Over, let's see, P -2, R -1. We also multiply the bracket again, Q cubed. Okay? So gather all your P's together, all your Q together. So let's see, we got Q here, we got Q here, and then all your R's together. Okay, so we apply our law of indices. P -2 divided by P -2 will be P to the power of -2 plus 2. Okay, so you'll get P0, all your R, add it up together, you get -5, and Q, you'll get -2 over 3. Okay, so A, B, C, 1 mark each. Okay, where you get your power. A, B, C. 3 marks. Okay, I think this one shouldn't have an issue. All good? Follow through, huh? Okay, second one. On the axis, sketch the graph of y equals to modulus 4 minus 3x, stating the intercepts with the coordinate axis. Okay, so we gotta state the intercept. Number one, we need to know what's the shape of this equation. So 4 minus 3x, if you are getting confused, right, like how to draw it, like for your modulus, I always advise to draw the original graph first. So what you want to do is you draw the y equals to 4 minus 3x graph first before you even sketch it out. Okay? So for what we want to find, your x-intercept and y-intercept. In this case, if it's if you draw the original one, it will be -4, then 4 over 3, right? Yeah, I'll just draw dotted. This is the original one. Then, because it's a modulus, so we inverse it. Okay, so here is 4. Make sure you show your shape correct, which is this V shape, and then your intercept also is correct. Okay, because they ask you to show the intercept. So first one, shape, 1 mark. Your both intercepts, 1 mark. So your x-intercept and y-intercept, x equals 0, y equals 0. Okay, so 2 mark question. Okay, question B. Solve the inequality modulus 4 minus 3x modulus more than or equals to 7. So you can either square both sides or you can just put plus minus over here. Okay, so I'll just do the plus minus one. You get positive 4 minus 3x more than equals to 7. Here, minus 4 minus 3x more than equals to 7. Okay, we split it into both of these. Let's solve for the positive one first. Negative 3x more than equals to 3. X less than equals to negative 1. Over here, if we want to divide the whole equation by negative, your symbol will change. So become negative 7. Okay, negative 3x, negative 11. Actually, you don't have to solve it like this. You all just move it as it is. Okay, just take note that when you do your, when you want to move your negative, which means you times or divide the entire equation by negative, your symbol will change. Okay, your final answer will be x more than equals to 11 over 3. Any questions? This question? Okay, let's move on. Third question. The diagram shows a quadrilateral OABC such that OA equals to A, OB equals to B, and vector OC equals to C. The lines OB and AC intersect at the point P such that AP to PC equals to 3 to 2. Find OP in terms of A and C. Okay, so if we look according to this diagram, OP is in the middle, right? Okay, not exactly in the middle. They gave us the ratio AP to PC is 3 to 2. So let's just write that down first. 3 to 2. What else do we know? OP. Okay, so we can take, since we know 3 to 2, we can take OP is equals to OA plus AP. Okay, or OC plus CP. Can we take OC plus CP? Possible also, right? Okay, but let's just take OA plus AP because we want it in terms of A and C. So OP is equals to OA plus AP. Okay, but in the question, they gave us also AP to PC. That means this whole AC line is 3 to 2. Okay, so let's find what is AC first. AC would be AO plus OC, which will give you negative A plus C. Why do we want to find? Because AP is part of AC. Okay, and how many parts of it? 3 out of 5 parts. Okay, so OA, A plus 3 over 5 AC. And we'll just count it. So AC would be negative A plus C. Okay, you add it up together. A minus 3 over 5, you get 2 over 5A plus 3 over 5C. Okay, so this is actually called ratio theorem. Pretty simple. They can either give you from first point to middle point, then middle point to the end point, or they can use first point to last point, then the first point to one of the middle points. So you all need to read the ratio properly also. It's not always 3 to 2. Sometimes they might write it like you need to think a bit, but it's just parts of ratio theorem. Okay, so this one I think quite straightforward. Another thing they give you here, given that OP to PB is also 2 to 3. So we know here is 2 parts, here is 3 parts also. Show that 2B equals to 3C plus 2A. Okay, so what can the question to ask is what can we compare with? Okay, just now we found OP already, but in terms of A and C. Now they want us to prove an equation that has B, C, and A. Okay, and also given to us OP to PB is equals to 2 to 3. Okay, so what is common between both of these, or what can we compare, are OPs. Because if you look straight in the diagram, OP is already B. So we know OP, we can express it in some sort of, in terms of B also. Okay, so let's find OP in terms of B. So OP to PB is 2 to 3. So what can we conclude? OP is 2 over 5B, because 2 parts out of the entire 5 parts, where OB is equals to B. So now that we got this, we compare with the OP that we found in A. Okay, in A. So we can write 2 over 5B equals to 2 over 5A plus 3 over 5C. Multiply the whole equation by 5, you get 2B equals to 2A plus 3C. 2-mark question. Okay, vector is the vector diagram question. Okay, you all hope this one come out instead of the speed velocity one, okay, the relative velocity one. But you all need to know also lah, that one. Okay, let's move on. Question 4. A curve is such that d square y over dx square equals to 3x plus 2 to the power of negative 1 over 3. So we have this. The curve has gradient 4 at point 2, 6.2. Find the equation of the curve. So we want to find what is y. Given to us d square y over dx square, we integrate it. Okay, so d square y over dx square, we want to go up to dy over dx, then we want to find y. So up, up, here, you integrate. Okay, so given to us the gradient and the point also, why do we need to, why did they give us? So we have to question all these things, is to find your C and find your D. Okay, so let's integrate it first. D square y over dx square, we integrate it, so you'll find dy over dx. Integrate this 3x plus 2 negative 1 over 3 dx. Okay, so if we were to integrate it, the power, okay, let's add the power first. Negative 1 over 3 plus 1, we'll get 2 over 3. So we divide 2 over 3, which will give you divide 3 over 2. Differentiate the inside, 3x plus 2, you'll get 3. Okay, so we got 3 and 3 here. We can simplify it and make sure you put your plus C here. Let's rewrite it. 3x plus 2, 2 over 3 plus C. Okay, so given to us dy dx at the point 2 and 6.2, so we can sub in dy dx equals to 4 and x is equals to 2 to find our C, which will give us 4 equals to half 3, 2 plus 2, 2 over 3 plus C. Okay, oops, which will give you C equals to 2. Okay, so we got our dy dx equation already. We would need to integrate once more to find our y. So y is integrate our dy dx equation. So will be half 3x plus 2, 2 over 3 plus 2 dx. Okay, so check this because if you get this wrong, then your second part will be wrong already. Okay, so let's integrate this again. 3x plus 2, 2 over 3. So what I will do, 3x plus 2, add 1 to the power first. So you would get 5 over 3. You divide 5 over 3 will give you 3 over 5. And why I got one more extra 2 one? Hold on, let me see a bit. Five times 3. Oh, I blur already. There's extra 1 over 2, right? 1 over 2 plus 2x plus d. Simplify it. 3 cut it off. And we will get 1 over 10 3x plus 2, 5 over 3 plus 2x plus d. Given to us, we got to sub this in, 2 and 6.2. Okay, right here. So we get 6.2 equals to 1 over 10, 3 times 2 plus 2, 5 over 3 plus 2 times 2 plus d. Type this in the calculator. D would be equals to -1. Final answer, y is 1 over 10, 3x plus 2, 5 over 3 plus 2x minus 1. Okay, 6 marks question. Okay, so this is just the power rule kind of integration. All good, this one? Okay, so you'll see the mark scheme on my mark scheme on how to get the marks, the 6 marks there. Okay, we've done 5a. Given that log AP plus log A5 minus log A4 equals to log A20, find the value of P. Okay, find the value of P. So, how do we do this? Whenever you see everything here, there's something that's common, which is log A. We want to have one big log A at the left-hand side, one big log A at the right-hand side. Then we can just compare the arguments. Okay, so follow the rules, or you call it what, the law of logarithms. So here the plus one, you multiply, so multiplication law, 5p minus divide equals to log A20. Okay, then you compare the arguments, 5p over 4 equals to 20. Multiply 4, divide 5, p equals to 16. Okay. 5b, solve the equation 3 to the power of 2x plus 1 plus 8 times 3 to the power of x minus 3 equals to 0. Okay, so this is the kind of question that falls under your complex quadratic equation also. You need to recognize the form. Otherwise, you might be cracking your head a bit on how to actually simplify this equation. So I'll simplify it for your the official mark scheme might do a different method which you can follow also. Okay, as long as your answer is the same, it's totally fine. Okay, so what I will see is that the first term and the second term, there's something that's common, which is 3 to the power x, right? Okay, 3 to the power x. So that's your common term. If you see the mark scheme, they straight away factorize it. But I think most students would find it a bit hard to see at first. So I'll simplify it to a quadratic equation first. So whenever you see the 3 to the power of 2x plus 1, make sure you break it down to this manner first. Okay, put it into the different bases. So 3 to the power of 2x times 3 to the power of 1 plus 8 times 3 to the power x minus 3 equals 0. Okay, then we want to put the one with power x. It's like as if your term, okay, your term that you want to factorize and all, like your ax squared plus bx plus c, right? So what is the term right here that we want to factorize? 3 to the power x. Okay, 3 to the power x. So we want to make a 3 to the power x come out. We put the 3 in front, which will be your coefficient. 3 to the power of 2x can be written as 3 to the power of x squared also. Okay, plus 8 times 3 to the power of x minus 3 equals to 0. Now, if we put it like this, then we can use the lab method. You don't have to do this, okay? Just so you all know, if you all can straight away factorize it, just go ahead and factorize. Okay, but for me, and I think to simplify for most students, is we do use the lab method, okay, so that we can see it clearly. Even when you all go to college, right, you all will see terms that are very complex, right? So what you all want to do is take the common terms and simplify it first. Okay, always take the common terms and simplify it first. So sometimes might be, okay, I just give you all a scenario. Maybe there are a few terms that are log ABC. Okay, log ABC, 1 log ABC square, 1 log ABC cube, 1 log ABC to the power of 10. So you always want to simplify it first. Then only you sub it back to log ABC. Okay? So you can write it as 3u squared plus 8u minus 3 equals 0. Factorize it, 3u minus 1, u plus 3 equals to 0. You get u equals to 1 over 3, u equals to negative 3. Okay. 3 to the power of x is u. Okay, so we sub it back. 3 to the power of x equals to 1 over 3. This one 3 to the power of x equals to negative 3. Okay, you need to know this is that if you try to solve the negative value, you'll get a math error. Okay, why? You all see, lo? Exponential graph, there's no negative. Okay, so there's only positive. 3 to the power x, okay, write it over here, can be written as 3 to the power negative 1. Therefore, x is equals to negative 1. Okay, 3-mark question. Okay, any question for this? Can everyone do? Okay, can. Any questions? Lost 3 marks. Really? Okay. Yeah. Okay. But as long as you learn this, I want you all to take note on the 4. I think there's 4 different complex quadratic equation. So you all need to recognize the form how they actually present it. Okay, so as long as you know how to simplify it, I will always simplify it lah. So the lab method is the technique I always use. Even in college, go to uni also, when I do my math, okay, I always use this method. Because your brain don't want to think in so complex. When you got so many terms, right? And if you think in very complex terms, you might your brain might get tired also. Log question. Yeah, it might, I mean, possibly it could be, right? But I don't think you can simplify to a log until the final step only. Okay. Okay, cool. Let's go to question C. Solve the equation 4 log base y2 plus log 2y equals to 4. Okay, 3-mark question. For this question, you can either change all your terms to log 2, log base 2, or log base y. Up to you. Okay? Both also, you should get the same answer. Which one right, which one wrong, which one easier or not? I think both also will be the same steps lah. Okay, so I'll show you all for changing it all to log base 2. So this term is the log y one. We want to change it to log base 2. So let's just change the log y term first. Log y2. Okay, we do change of base. So it'll be log 2 argument over log 2 y. Okay, which you will get 1 over log 2y. Okay, so that's for the first term. So 4 times log y2 now become 4 over log y2 plus log 2y equals to 4. Okay, I got one log 2 at the bottom, one log 2 on top. So what I want to do, make all the log 2 on top, so you can change it to a quadratic equation also. So 4 plus log 2y squared equals to 4 log 2y. This question, if you want to use let method also, you can do it. Okay, so that it's easier for you all to see. Okay, so if you cannot see it, always simplify it. The constant, I wrote something wrong here. This is log 2y. Log 2y. So how we can see it also, we can let log 2y equals to u. So 4 over u plus u equals to -4. So you ask yourself, well, how can I find u? How can I find u? Okay, so 4 over u plus u equals to -4. Multiply it by u, then that's how you find your u. Okay. I will just solve it in terms of log. So it's a quadratic equation, which is log 2y squared minus 4 log 2y plus 4 equals to 0. Factorize it, log 2y minus 2, log 2y minus 2 equals 0. Okay, where you get log 2y equals to 2. We change from log to indices form, y equals to 2 square, which is equals to 4. Okay, you can solve the entire equation with log base y also. It's totally fine. Okay, your final answer should be the same. Okay, who is maintaining at a perfect streak right now? Anyone? 0 wrong. Jensen? No, with a smiley face. Okay. Okay, let's move on. Question 6. A curve has equation y equals to bracket 3 plus surd 5 bracket x squared minus 8 surd 5x plus 60. Find the x coordinate of the stationary point on the curve, giving your answer in the form a plus b surd 5. Okay, so stationary point, which means dy over dx equals to 0. Okay, because stationary point, your gradient will be equals to 0. Okay, so let's find what's dy over dx first. Dy over dx equals to, okay, we just need to differentiate the x squared. So with 2, 3 plus surd 5x minus 8 surd 5 plus 60. What plus 60? No, it's plus 60. Differentiate already. Okay, so dy over dx equals to 0. Therefore, 0 equals to 2 plus 2 times 3 plus surd 5x minus 8 Surd5. Okay, we shift the 8 over Surd5 to the other side, and then we divide it by 2 times 3 plus Surd5. So it will be x equals to 8 Surd5 over 2, 3 plus Surd5. Okay, we want it in that form, a plus b Surd5, so we have to rationalize. Rationalize bottom and top, we just multiply it by 3 minus Surd5, which is the conjugate Surd. Okay, the conjugate Surd. You don't have to multiply it by the 2 actually. Oh wait, it's actually, you can simplify it also. Simplify. Okay, later I need simplify lah. Okay, so it should be 4, can be written as 4 Surd5. So 4 Surd5, you know what, I'll just change it to 4 Surd5 first. Easier for me to solve. Okay, multiply it, you'll get 12 Surd5 minus 20 over 4, which we can simplify it. 12 divided by 4 will be 3. We want it at the back, plus b. Then 20 divided by 4, you'll get negative 5. Okay, 4-mark question because they want the Surd5 on top. Okay, all okay? All right, let's move on to question B. Hence, find the y-coordinate of this stationary point giving your form in the form c Surd5, where c is an integer. Okay, so we just need to sub in. We've got the question gave us over here is y equals to 3 plus Surd5x squared minus 8 Surd5x plus 60. All we need to do is sub this x into the question. Okay, sub it back into the question to find our value of y. Okay, so what we'll get? Y equals to 3 plus Surd5 negative 5 plus 3 Surd5 squared, which is my x squared, minus 8 Surd5, 3 Surd5 minus 5 plus 60. We open up the square first. So 3 plus Surd5, 45 plus 25 minus 30 Surd5. Multiply this into the bracket. We will get minus 120 plus 4 Surd5 plus 60. We cross multiply it. You'll get 210 plus 70 Surd5 minus 90 Surd5 minus 150 minus 120 plus 40 Surd5 plus 60. Okay, if I want to gather all the Surd5 term together, it will be this. The non-Surd5 term will be here. Okay, yellow one all will minus off with each other, it becomes 0. 70 minus 90 plus 40, you will get 20. So you get 20 Surd5. 3-mark question. Cool. And I can have confidence in all of you. I believe in you that y'all can fly. Okay, let's go. Question 7. All right, a 6-character password is to be made from the following 8 characters. So your digits, you got 1, 3, 5, 8, 9. Symbols, you got star, dollar, hash. No character can be used more than once in the password. Find the number of different passwords that can be chosen if there are no restrictions. So no restrictions. Order methods, we use permutation. So 8p6, because we only want 6, you'll get 20160. Second one, the password starts with a digit and finishes with a digit. Okay, starts with a digit and finishes with a digit. So 1, 2, 3, 4, 5, 6. Starts with digit, end with digit. So if at the start, I got how many digits? 5, P, 1. Okay. Second time, if I want to use another digit, I still left with 4 digits. So 4P1. Remainder in the middle, I can use both digits or symbols, which I have another 6 more of it. So I can 6P4 because I got another 4 more spaces to use, which would be 7,200. Okay, so this is a 2-mark question. 2-mark question. Okay, question 3. The password starts with 3 symbols. So symbol, symbol, symbol. The other 3 not necessarily need to be digits, so it can be anything. So symbol, symbol, symbol. Oh wait, there's no other symbol already. There's 3 only. So 3P3 for this first one. Then your over here is digits, which you have 5 more digits. 5P3. So 3P3 times 5P3, you'll get 360. Okay, 360. Okay, question 7b. Okay, this is a fun one. That day, I think some of you were asking when you all did it. Okay, the number of combinations of 5 objects selected from n objects is 6 times the number of combination of 4 objects selected from n minus 1 objects. Find the value of n. So, gotta remember, if our n is unknown, okay, if our n is unknown for a combination kind of question, then we have to use the formula. What is the formula? Go to your formula sheet. It'll give you n factorial over n minus r factorial, r factorial. Okay, n factorial over n minus r factorial, r factorial, and this is NCR. Okay, so what did I say? The first one is NC5, right? 5 objects selected from n objects. So NC5 is 6 times of what? So 6 times of 4 objects selected from n minus 1 object. So n minus 1 C4. Okay, n minus 1 C4. So this is the equation that we want to expand and we want to solve. Okay, so we fit into the formula. It will be n factorial, n minus 5 factorial, 5 factorial, then 6. Okay, we write here 6 first. Then we write the n minus 1 factorial. Now your n is n minus 1 factorial over n minus 1 minus 4 factorial, 4 factorial. Okay, recognize this pattern. If you all see the n factorial, then n minus 1 factorial or n minus 2 factorial, do know that your n factorial, the next term is n, then n minus 1, n minus 2, n minus 3, n minus 4. In a way, it's also n, then n times n minus 1 factorial. Okay, so your n factorial can actually be written as n times n minus 1 factorial. And the reason why we stop here is because the right-hand side also got an n minus 1 factorial, which we can cut with each other. Okay, so we stop at n minus 1 factorial. So n minus 5 factorial, 5 factorial equals to 6n minus 1 factorial over, at the bottom here would be 9 minus 5 factorial, 4 factorial. Okay, this is good. Why? Left hand side, right hand side got n minus 1 factorial. So I can cut and cut. Bottom also got n minus 5 factorial on both left hand side and right hand side. Okay, so I'm left with what? N over 5 factorial equals to 6 over 4 factorial. Calculate your n, you'll get n equals to 30. Okay, n equals to 30. Okay, who is still unclear on how to use this this formula, this NCR formula? Okay, we've done quite a number of questions on this based on the past year question, and it's a potential question that will come out also. Okay, so you all need to know how to apply it. Clear? Okay, if clear, can give me a, let's say clear. Okay, clear in the chat so that I know that you all are okay. Not clear, then say blur. Okay, still blur. Okay, 清楚. Nathan. Blur a bit. Which part blur? N minus 1. N minus 1, you just replace the n. It can be n minus 1, it can be n plus 1, it can be n minus 5, it can be n anything. Okay, as long as you replace the whatever term that they give you for the n. You follow the formula. Then you want to simplify it. Okay, because you don't want any n with a factorial. Okay, if you got a factorial, you got an n with a factorial, then you actually won't be able to solve the equation because we don't know what's n. So we don't know what's the start, we don't know where's the end also. Yes, because we don't know lah. We basically want to solve the n. So you need to eliminate all the n factorials away. Any n that has a factorial with it, that's our goal to eliminate first. Okay, Luis, later you try again. Okay, just try again to really understand it. If you are unsure, you try this, then later you look back at the previous paper also. Okay, because the previous paper has a similar kind of question. Okay, a very, very similar kind of question. Okay, let's move on to question 8a. Variable x and y are such that y equals to ax to the power of b, where a and b are constant. When log y is plotted against log x, a straight line graph passing through the points 0.61, 0.57, and 5.36, 4.36, 4.37 is obtained. Okay, so we got all of this information. Log y against log x. Find the value of a and of b. Okay. 5 marks question. So now they are saying this graph, log y against log x. Okay, we got a straight line graph. Might be down, might be going up, but we know it's a straight line graph. So we need to make it in a form big Y equals to m big X plus C. Right? Y equals to mx plus C. Okay, with that, how do we do it? So we want to change this y equals to ax to the power of b into a straight line equation form first. We got power b, we want to bring out the b, and we want a log y and log x to appear. So we multiply it by log ax to the power of b Okay, this one is this whole thing, which you will get log A plus log x to the power of b. Your b, you can use power rule, bring it down. Okay, I shift it here so that we can write it in the form y equals mx plus c. So you see, over here, this form is y equals mx plus c. Can see? Can recognize this form? Y equals mx plus c. Okay, so with this, they want us to find value of a and of b, right? They gave us 2 points. Okay, so we can just sub it in. They gave us 2 log x and log y points, right? So the coordinates 0.61, 0.57, and 5.36, 4.37. You're gonna know this is not x and y. This is log x and log y. Okay, for both of it, both here and here. Okay, so if I were to substitute in the 5.36 and 4.37, it will be 4.37 equals to 5.36b plus log a. This one will be 0.61, 0.57, which is 0.57 equals to 0.61b plus log a. Okay, so we got 2 unknowns. What I'll do elimination because we have both log a on the first equation and second equation. So if I take this as first equation, this one as second equation, I'll do 1 minus 2. So 4.37, this one, just minus it off. The entire equation, you'll get 3.8 equals to 4.75b, where your b will be 0.8. So until here, 3 marks already. After you find b, now we want to find a. So we want to sub b equals to 0.8 into the equation. Okay, so we can sub it straight into the log y. Okay, the log y equals to log, this one, what do you write here? B log x plus log a. Okay, then we can also take 1 point, b, and this point, let's take 4.37 and 5.36. You got to sub all of it in. Okay, so you get 4.37 equals to 0.8 times 5.36 plus log a. Log a will be equals to 0.082. A equals to 10 to the power of 0.082, which will give you 1.21. Okay, you might use a slightly different method. It's totally fine. Okay, as long as you get to 1.21 over here. Okay, 5-mark question. Okay, great. Everyone feeling great? Okay, let's do B. You got to get this right, Your A, B wrong, B and C all wrong already. Okay, it's 4 marks here, 2 marks, 2 marks. Okay, so using your values of A and B, find the value of Y when x equals to 3. So just now, what did we find? 1.21 and 0.8. So when x equals to 3, y equals to 1.213 to the power of 0.8, and you'll get 2.91. Okay, 2 marks. Same goes for question C. Just sub in your y value when it's 3 So 3 equals to 1.21 x to the power of 0.8. X will be 0.8 root 2.479, which is your 3 divided by 1.21. You'll get 3.11. PTSD. Okay, any question? No question, that means it's full marks already. How are you? I'm assuming that y'all will get most full marks for this. Okay, let's move on to question 9. The first three terms of an arithmetic progression are -4, 8, and 20. The smallest number of terms, find the smallest number of terms for which the sum of this arithmetic progression is greater than 2000. Okay, so for us to use sum, we need the value of A and D. Right now, we don't have, but we know that this is an arithmetic progression, and we know the first three terms, which is -4, 8, and 20. So what can we find from -4, 8, and 20? A is -4, D is Tn plus 1 minus Tn. Okay, so I can get 8 minus -4. You just need to minus the term before. You can take 20 minus 8 also, you'll get the same answer, 12. Okay, so they say the sum of this arithmetic progression, so Sn is more than 2000. Okay, so we use a formula, n over 2, 2a plus n minus 1 d is 12. There's more than 2000. Okay, simplify it. -8 plus 12n minus 12 more than 4000. Okay, you all might open it differently. You'll end up with 12n squared minus 20n minus 4000 more than 0. Simplify it. 3n squared minus 5n minus 1000 more than 0. Okay, irrational value. So we can use a quadratic formula. B squared minus 4ac over 2a. 2a. Okay, you will get 19.1. Okay, and there's one more value lah. Okay, you can use calculator to double check it. I think the other one will be a negative value, right? Okay, the other one is -17.4, so we can straight away reject that one because your n cannot be negative. Then 19.1, don't use 19.1, it needs to be a whole number. So n more than 20. If you all are unsure whether you use 19 or 20, just sub your value back into the equation, then to see which value will come first to more than 2000. Okay, if you all are unsure about the symbol, the more than 2000 or less than 2000, whether it's more than 19.1 or less than 19.1, make sure you all just double check it back with the question. Okay, don't straight away assume if you are unsure. Okay, Ken? All right. Question B. The 7 and 9 term of a geometric progression are 27 and 243 respectively. Given that the geometric progression has a positive common ratio, find the common ratio. Okay, 7, 9 term geometric, 27, 243, positive common ratio. Okay, so for you to find common ratio, you normally, for a geometric progression, you normally divide the terms. Okay, normally you divide the terms to find. So we got T7 equals to 27, T9 equals to 243. Okay, then we got AR to the power of 8. We can just use T9 divided by T7. T9 divided by T7. AR to the power of 8. AR divided by AR to the power of 6. 243 over 27. Okay, because we want to find R. And why we divide is because you got A that you can divide it off. R8, R to the power 8 divided by R to the power 6 will be 2. So R squared equals to 9. R equals to plus minus 3, which you only take positive. So R is equals to 3. Okay, R equals to 3. Okay? All right. Question 2. The 30th term, giving your answer as a power of 3. Okay, so do we know what's A? We don't, right? Okay, so we got to find what's A first. Let's just use T7 equals to 27. So AR n minus 1 equals to the term. Over here, you'll get 1 over 27. Okay, 1 over 27. 27 divided by 3 to the power 6 is 1 over 27. We want 30th term. Okay, 30th term, which is 1 over 27 R 29. Okay, they want it in terms of power of 3. So we can write it as 3 to the power of 29 over 3 to the power of 3, which will get 3 to the power of 26. Okay, or you can just type in a calculator, then just make sure that you know how to change it to 3 to the power, as a power of 3. Okay, question C. Explain why the geometric progression 1 sine theta sine square theta for negative pi over 2 to pi over 2, where theta is in radians, has a sum to infinity. All right, so criteria for sum to infinity is your R needs to be more than 1. Sorry, not more than 1. More than 1 pula. In between negative 1 and 1. Okay, in between negative 1 and 1. So let's find what's R first. R, for geometric progression, R is your next term, your Tn plus 1 divided by Tn. Because AR to the power, let's say AR to the power of 2 divided by AR. Okay, so you all got to remember this formula as well. Tn plus 1 divided by Tn. That's how you find your R. So in this case, your Tn plus 1, that means your next term, or we can say according to this progression, the second term is sine theta over the first term, sine theta over 1. This is term 1, term 2, term 3. You take term 3 divided by term 2, also same thing. So R equals to sine theta. Okay, so we got to see the criteria. You got to remember your R modulus R is less than 1. So your R actually needs to be in between negative 1 to 1. Okay, so how can you solve it? You use the range here. Pi over 2. You sine. Okay, we want sine theta to appear. So we can sine here to all the angle here. Sine negative pi over 2 to sine pi over 2. Sine negative pi over 2 is negative 1. this is actually the proof. Okay, why? Because your modulus is plus and minus, right? So it actually can be written as this also. Sine theta modulus less than 1. Less than is in between, right? Okay, according to our inequality. Okay, any question, this one? You got it right? Okay, we just want the sine theta to appear because that's R and that's a criteria for it. Okay, let's go 10A. Solve the equation sine alpha cosecant square alpha equals to 0 for negative pi alpha pi where alpha is in radians. If you just write sine, okay, sorry, Ethan asked, if you just write sine theta less than 1. No. You have to write the complete. Criteria. Okay, which is modulus R less than 1. Okay. This question. So we gotta simplify the entire equation first. Cosecant square theta is sine square alpha. Cosecant square alpha is sine square alpha. So let's do sine alpha over sine square alpha plus cos alpha over cos square alpha equals to 0, which will give you 1 over sine alpha plus 1 over cos alpha equals to 0. Okay? And then what we get here? Okay, when you got sine and cos, to simplify it, try to make it to a tangent. So we can write it like this. Negative 1 over cos alpha. Okay, we can inverse the whole thing. Cos alpha, which will give you sine over cos, which is tangent alpha equals to negative 1. Okay, so until here, 2 marks already. Tangent alpha equals to negative 1. Okay, clear this part here? Okay, so you got to remember trigo, when you want to solve for trigo, when you see sine and cos, most likely what you want to simplify it to is tangent, because tangent is sine divided by cos. All right. Then look at the range above. They say negative alpha to alpha. Okay, hold on. We need to find what's our base angle first. So alpha, shift tangent 1, we will get, okay, this one you might want to use another symbol because alpha in this case is already the angle. So I'll just write a base alpha. Okay, base alpha. You can write it as theta or any other symbols. Write it as A also can. Okay, the range that we want is negative pi alpha to pi. So this would apply to our ASTC graph. Okay, our ASTC graph. So what will happen is that my starting point right now is from negative alpha, which is here, to alpha. So the in front here, negative pi to pi. I keep saying alpha. Negative pi to pi. Negative pi means negative 180 degrees. Okay, you all know what's negative 180 degrees, right? So the first time it hits here, okay, this is negative pi. This is pi. ASTC, we want to find a tangent that is negative. So it will be second quadrant and fourth quadrant. This will be my base angle, Okay, so alpha, the alpha that we want to find, the angle would be here and here. Okay, so which is negative pi over 4 and 180 minus pi over 4, which is 3 over 4 pi. So this is your 3 over 4 pi. This is your negative pi over 4. Okay. Yeah, I think the later got one more is the angle one, which is question B2 for this. Okay, show that cos theta over 1 minus sine theta plus 1 minus sine theta over cos theta equals to 2 secant theta. So this is a proving question. Okay, proving question. Okay, so we take the left-hand side. Left-hand side, we join it together. So we want our denominator to be the same. So it become cos square theta plus 1 minus sine theta square over cos theta 1 minus sine theta. Okay, which will give you cos square theta plus 1 minus 2 sine theta plus sine square theta over what? Cos theta 1 minus sine theta. Okay, so sine square theta plus cos square theta is 1. Okay, 1. So 1 plus 1 minus 2 sine theta over cos theta 1 minus sine theta. Okay, so you got to recognize this. Your 1 here. So become 2 minus 2 sine theta over cos theta 1 minus sine theta. Here you got a common factor, so 1 minus sine theta over cos theta 1 minus sine theta. Cancel, which is 2 over cos theta, which will give you 2 secant theta. Okay, easy, this one, the proving question. Okay, if you're unsure, right, sometimes you want to work from the right hand side also. So 2 secant theta, you see. Okay, 2 secant theta is 2 over cos theta. Then actually a bit hard to you just need to try to connect back into the middle. Okay, because 2 over cos theta, you can't do much really, but you know eventually you want to get a 2 over cos theta. So that's a clue also. Okay, the next one. Okay, this is an important question that I want you all to take note. Hence, solve this equation. So you want to compare it with the top one. So what is replaced? Okay, that day I just Googled what is this symbol called, but I forgot again. Okay, but I'll just call it theta for now. Wait, I cannot. Greek symbol. I just wrote it down. Want to know the proper name. Okay, fine. Already. It's called phi. 中 3 中 good one. Yeah, if maybe the Greeks were speaking Mandarin also. Okay, phi, P-H-I. Okay, so if you all see here, the theta is replaced by 3 phi, right? Okay, so we can say that this whole equation on the left-hand side is equals to 2 secant 3 phi. 2 secant 3 phi equals to 4. Okay, we want to solve for this. Equals to 2 cos equals to 1 over 2. Okay, then we want to find our alpha 60 degrees. Okay, we shift cos. Okay, but what we need to take note here, the range that is given to us, 0, phi to 180 degrees, but what we want to solve is 3 phi. Okay, so we gotta multiply it by 3. 0 times 3, 0, 3 phi, 180, 540 degrees. Okay, so you see 540 degrees is also not 3 full rounds. It's actually 2.5 rounds. So if we were to draw our ASTC graph out, how would it look like? Okay, so like this. We start from 0, 1 round, then stop here. Okay, so this would be 0, 360 degrees, and here 180 degrees, 540 degrees. Okay, it stops here. Follow back our ASTC rule. So ASTC cos positive first quadrant, fourth quadrant. Okay, first quadrant, fourth quadrant. We want to see these 3 angles that intersect. So the first time I intersect, 60 degrees. Then over here, 300 degrees. The second time on that line is 420 degrees. Okay, so 3 phi is equals to 60 degrees, 300 degrees, and 420 degrees. Where your phi is equals to 20 degrees, 100 degrees, and 140 degrees because we divide it all by 3. 完美, 完美. Okay, y'all got this correct? Okay, this one, please get it right. Okay, every paper also it has been coming out already. All the angle. Okay, if you're not sure, please ask. Identify which part you're not sure. Okay, the angle part, I think most of you struggle with the defining the angle. Okay, I think Nathan that day was sharing how he did also is sometimes you don't know, right? You're a bit unsure. So you just find all the angles, then your final answer, later you just reject it. Okay, if it's out of the range. Okay, so you might find 60 degrees, 300 degrees, 420 degrees. You might add on to 660 degrees because you keep adding on 360 degrees to it. So you just find, okay, you think it's like what, 3 rounds, right? So you find 3 cycles, but later on, you also need to reject the value. Okay, don't put the final, like the one that's not part of the range, the values inside. Okay, so you can do that way also. It's just that better if you understand like what's the question actually asking you. Okay, the negative side one also same thing. Okay, negative side. So if I give you this one was negative 180 to 180 degrees, just draw it out on the ASTC graph. Then it'll be actually very easy for you to solve already. Okay, but if you're unsure, you can do like Nathan, what he shared that day. Find all the angles, even the negative side. Just find like, I don't know, maybe don't find so many Okay, don't waste your time doing it. Put it all already, calculate it. The ones that don't fall within the range, then just reject it. Okay, your final answer, you don't write so many answers. Don't write like, this one only got 3 answers, you go write 6 answers come out. Okay, you will be wrong. Okay, and the final one. The final countdown. Okay, the normal to the curve. Y equals to ln bracket x squared plus 2 over 2x minus 3 at the point where x equals to 2 meets the y-axis at the point P. Find the coordinates of P. Okay, normal to the curve. So we got to find dy over dx, which is finding our gradient. Normal m1 times m2 equals to negative 1. Okay, so y equals to ln x squared plus 2 over 2x minus 3. Okay, we gotta do quotient rule to find our dy dx. Ln x squared plus 2 v equals to 2x minus 3. U prime 2x over x squared plus 2 v prime equals to 2. Okay, dy over dx, what would you get? Oops. 2x minus 3, 2x over x squared plus 2 minus 2 ln x squared plus 2 over 2x minus 3 squared. Okay, over here, do until here already, 3 marks. Then we want to substitute x equals to 2. So when x equals to 2, dy over dx equals to negative 2.92. Okay, your gradient of normal, so m normal is equals to, you can just write negative, then 1 over that value, which is using your m1 times m2 equals to negative 1, 0.3428. Okay, so this is your gradient of normal. Any other answers will be wrong. We want to find our equation of normal, so we need one gradient, 1 point. Point means x and y. We have x equals to 2. Can we find y? Just sub it back into the equation. Also, right, this part here, your dy dx, okay, they never ask you to simplify it. Don't go and simplify it. Just leave it like this. Okay, just leave it like this, then sub in your x value into it. That's all you need to do. Okay, because when you try to simplify it, chances of getting a mistake will be higher. Okay, so things that you don't need to do, don't go and do it. Okay, so when x equals to 2, we want to find our y. Y equals to ln 6, which is equals to 1.79. Now, we want to find the equation of normal. Y minus y1 equals to mx minus x1. Okay, we can just leave it here because we want to find p, right? So at point P, because intersects the y-axis, so x equals to 0. Okay, just sub into that equation above, you'll get y equals to 1.11. Woohoo! 11 questions done. Okay, cool. All good. Good. Okay, I'll stop the recording first. Very good.